Thanks for joining us today for our Mixed Up No More, Achieving Clean Identification and Separation of Compounds with your Go Direct Mini GC webinar. I'll pass it over to our presenters, Melissa and Noose, in one moment, but I just wanted to go over a few housekeeping items while people are joining us. We are recording today's session, and that recording will be available on our website after today, and you'll also receive a follow-up email with the links to the recording, and I'll be sharing a link to a folder that includes additional resources as well as the certificate of attendance. We'd love to answer your questions throughout today's session, so feel free to use either the chat or the Q&A. We'll be monitoring both of those. If we happen to not get to your question, we will definitely follow up with you afterwards. So with that, I will pass it on to Melissa and Noose.
Hi, everyone. I'm Melissa, and I am one of the chemists here at Vernier. I previously taught at the college level before starting at Vernier about 12 years ago. And at Vernier, we wear lots of hats. We're a pretty small company. So I work on not only like these types of trainings, but also product development. In fact, the Mini GC has been one of the products that I have helped develop over my tenure here. And so that's what we're going to be talking about today. And I'm joined with Noose. He's going to introduce himself.
Hi, my name is Hill Hisim. I taught 34 years in Maryland, chemistry and physics, and I've known David Vernier since 1984, pre-internet time. So I've used all this stuff, including, we were just talking about the GC, and I had some version of a GC hooked up to Logger Pro in the early 90s, and so we'll talk more about that later on. But I'm looking forward to the webinar, and I'm going to be kind of the monitoring the chat and trying to answer questions. Note that I said trying, and so I will probably be tagging Melissa and saying, hey, I don't have a clue about this one. But please just hop in there and let us know any questions you have, and that's my job, is to try to answer them for you.
Yeah, definitely. Noose is going to interrupt me if a burning question comes in. Just put them in chat, put them in Q&A. And we're here to answer your questions. So let's go ahead and jump right in. We're going to be talking about today the 3 different versions of Mini GC. So we've had over the years 3 different versions: the original Mini GC, the Mini GC Plus, and now we have the Go Direct Mini GC. They are all slightly different. They all detect slightly different chemicals. They all require slightly different temperature pressure profiles. And this has created a lot of confusion. So that's one of the motivations behind today's webinar. And it's something I'm going to really try and address. So we're going to review a lot of the common questions around Mini GCs in general, and then in particular about how to achieve really good separation with your Mini GC, especially if you're kind of going off the book. So we have lots of pre-printed experiments that will guide you through getting good separation for your samples. But if you're wanting to kind of go off the beaten path, we can help you set that up, and that's what we're going to be talking about today. So we're going to do some live data collection to show you best practices for that type of application, and we're going to do it in instrumental analysis. And I know there's a lot of questions around instrumental analysis, LabQuest, Logger Pro, all that good stuff. So we're going to tackle all of those things, as well as the common applications for high school and college. We get a lot of questions about how do I use this at the high school level. So we're gonna tackle all of those questions and any other burning ones you guys have that come in through chat. Okay, so the Vernier Mini GC, like I said, we started with the original Mini GC in about 2008, 2009, and sold it all the way up to 2012. Then we had the Mini GC Plus between 2012 and 2020. So the majority of people have a Mini GC have the Mini GC Plus. But now we have replaced the Mini GC Plus with the Go Direct Mini GC in 2020, and that is what we are currently selling. And all of them have some things in common. So let me pull up my live feed here. So all of them you inject directly into the column. So here's my Mini GC. This is my injection port, this brass area right here, and this is directly into the column when you inject. All of them come with a 1 microliter Hamilton syringe. So this is my 1 microliter Hamilton syringe. It is for liquid samples. And the injection volumes you will inject for any, again, this pertains to all the original, the plus, and the Go Direct. The most I've ever seen needed was 0.6 microliters. We really don't want anyone injecting more than that. Typical injection volumes are between 0.2 and 0.4 microliters. All of them use room air as the carrier gas. So you'll see I do not have a tank hookup to here. It's not under the table. It's just using room air. The maximum temperature range has been the same for all 3 of them. Right now it's at 160. The plus was at 160 degrees Celsius. The original was 120 degrees Celsius. All of them have gone up to 21 kPa as pressure, and all of them have been about the same size. So we used to say it was the size of a shoebox, but it's kind of a weird shaped shoebox. You can see that's my hand. So it's pretty small. It really fits nicely on a benchtop space, and it's great for the educational environment where you don't have a lot of benchtop space. So the differences between the Go Direct version and the Mini GC Plus and Original are: 1, the Go Direct has built-in Bluetooth, so you can connect via Bluetooth, but you can also still connect via USB. The original Mini and the Mini GC Plus were USB only. But really the bigger difference that's caused kind of more of the confusion is the fact that the Go Direct Mini GC can detect so many more compounds. So this is, I love telling this story because it really it showcases how Vernier works with educators and how much we really try and design products for y'all. The Mini GC Plus, all over those 8 years we were selling it, all we heard was that it needs to detect more compounds, that it only did polar compounds. So it had to be alcohols, esters, ketones. That's all it could do. They really wanted non-polars. So now the Go Direct Mini GC will also detect polars. So everything you did with the plus, and now it will also detect non-polars. So your alkanes, your hydrocarbons, your all that good stuff that we're going to get into. So it detects a whole new swath of chemicals, but that meant we had to change both the column and the detector. So that's where some of the trickiness gets in. So the column we changed. Now, remember our chromatography 101, you have a mobile phase, which in this case is room air, and you have a stationary phase. So the mobile phase is carrying your sample through the column. You have the stationary phase, which is what is coating the column. So for the original and Mini GC Plus, this string of was coating the column. And so in order to get better separation between polars and non-polars in the Go Direct version, we added this 5% of this functional group here to allow for better differentiation between non-polars and polars. So that's kind of a nice little, I know a lot of people always want to know what's in the column, what's it being coated with. Refer to this. All these slides you'll get in that Google folder that Angie has been linking. And so it gave us better separation between polars and non-polars, changing the column, but then you still have to be able to see the non-polars. So we had to change the detector. Our previous generation was a polymer-based chemi-capacitive detector, and our current generation is a polymer-based chemi-resistive detector. Now, what does that mean? So polymer-based detectors are a little bit different than like an FID detector or something that we all were previously used to. This basically what this does is that as the chemical elutes from the column and interacts with the detector, it adsorbs to the detector. And as it desorbs, that desorption creates either a change in capacitance for the old Mini GC or a change in resistance for the new Mini GC, which causes the peak. So that's where the peaks come from. And you'll see that kind of, I have some examples here of the GC Plus. Another comment we got that people wanted improvements was the shark finning. So this is like a bleeding off of the chemicals from the detector. So they wanted some improvements in all this shark finning and get more Gaussian peaks, which is kind of a more typical GC appearance. And the resistance detector has allowed us to do that. So that's kind of, you know, gotten some improvement. It's still not perfect. It's still not an FID detector. It's not a $20,000 GC, but it is getting a little bit more comparable to what students would see in the actual, in a technician job, for example. All right, so that's the big difference between the Mini GC Plus and the Go Direct Mini GC. And so now I want to conquer your common questions. So if you call up a chemist with questions about the GC, these are like the top 10 questions that we get. And by far and away, the number one question we get is, can I inject X compound? So you've read about something really cool in JChemEd or, you know, in Chemical and Engineering News, and you're like, well, I want to reproduce that. I want to do that. Can I do that? So odds are probably not. The first thing we're going to ask you, or that we're going to look up, is, does it have a boiling point less than 160 degrees Celsius? And again, this is because the Mini GC goes up to 160 degrees. So that's a pretty good line. And then, is it readily a liquid? Remember, these are 1 microliter syringes. You're injecting liquid. You're injecting between 0.1 and 0.4 microliters. So if you're just getting scrapings off of clothes, for example, you're not going to be able to inject it into the Mini GC. However, I also want to point out, we do have a list of compounds that are that the Go Direct Mini GC and the Mini GC Plus are able to detect. Now, if you look closely at this, you'll see that some of the compound types have an acceptable boiling point range higher than 160, and some of them have it lower than 160. So that's kind of, we use 160 as our kind of our benchmark, plus it's really easy to remember. And then if you're looking for something really specific, especially if you're going to be injecting it over and over again, if you want to put this into your Gen Chem lab and you're doing 4 sessions a day for a week, that's a lot of the same injection over and over again. You want to make sure it's within this list of acceptable compounds. And then we also have a list of that for the Mini GC Plus. So definitely check those out if you've ever thought, can I inject this compound? The next question we get a lot of is, can I inject water? So this typically comes about because people want to inject consumer products a lot. So they want to inject beer or wine or distilled spirits, anything along those lines. No, you cannot inject those into the Mini GC. A large amount of water will completely damage the detector. However, we totally understand, you know, methanol and ethanol are not 100% solutions. They very much commonly have 10% water in them, and that is acceptable. So that's the answer to, can I inject water? Can I inject a gas? Yes, you can. For headspace analysis, again, look at the list of acceptable compounds. Those compounds still apply. But if you're trying to do headspace analysis, you do need a different syringe. So again, this syringe that it comes with, this Hamilton syringe, is for liquids. If you want to inject gases, you need to inject a much larger volume, up to 1 milliliter. is typically what I've done all my testing was with a milliliter. And you need a gas tight syringe and you need to purchase that from another company. So that's what this information is all about, to make sure you get the right gauge and all that kind of good stuff. So make sure you look at that till if you're interested in headspace analysis. All right, the syringe looks strange and fragile. I don't disagree. Let's go through all the points of this syringe and make sure you understand why each component is there and why it is fragile. One, it's a 1 microliter syringe, so it's going to be fragile. It's small volumes. A lot of people see this brown kind of bumper or, you know, just spacer here and think it's just for like packaging, and they take it off and throw it away. Don't do that. It needs to stay there. And what its purpose is again, you're injecting directly into the column. So it's designed so that you don't put the syringe all the way into the column, and then it will actually start to coil around the column if you take this spacer off. So you want to make sure that stays there. This is the plunger. The plunger is very thin. Again, it's a 1 microliter syringe. Do not pull the plunger all the way out. You will never get it back in. So that is why it is fragile. That is why it looks a little bit strange. And it is definitely worth spending some time going through with your students why it's fragile and proper techniques so that they don't immediately break it. All right, can I replace the column with something special I want to detect a certain thing, or I'm just going to take this mini GC and use it to detect beer and wine anyways. Can I request a specialty build of the mini GC? No, you cannot. This is designed for education, and we can't accommodate special requests, even if they are for educational use. What maintenance needs to be done on it? None, really. It's kind of designed that it does not need regular maintenance. The thing that I will point out that is kind of more about a typical maintenance, when you purchase the mini GC for the first time, it comes with this little bag of spare parts. And in there is 2 septa. And a lot of people will see this and be like, oh, I don't know what that is. And then they throw that away. Don't do it. You will need these septa. About every 1,000 injections, you will want to replace the septum. If you happen to see that the pressure is not being maintained, or if the temperature and pressure are not being maintained, it's time to change the septum. You do that right here, this brass injection port, a very fancy tool, we call it quarter, and you unscrew it. The septum's down in there. You just use some tweezers to take it out, drop in a new one, and then screw this back on. And again, it does not need to be super duper tight. Just tighten it down with a quarter, and you're good to go. All right, that's really the only regular maintenance that it requires. What's the difference between the Mini GC Plus and the GoDirect Mini GC? Can I still get the Mini GC Plus? There are several differences. We outlined them already. There is a very nice till here that outlines all of them. If you need them for future reference or want some more details about some of them, this is a great place to come. And we no longer sell the Mini GC Plus. We only sell the GoDirect Mini GC. And then last but not least, my favorite question, my Mini GC doesn't work. So again, if it's not coming up to pressure, if it's not maintaining pressure and temperature, replace the septum. In fact, Noose just had a customer the other day that was, they weren't convinced. They're like, okay, I get why pressure, but my temperature is not coming up. And sure enough, right, Noose, just changing the septum changed that.
She was really excited. She was like, "Awesome, it worked!" Yeah, yeah, it was super easy to do. Just hang on to them, don't throw them away, like Melissa said, to make sure they stay in the case.
Yeah, for sure. So the next thing you'll encounter is that you don't get any peaks, right? This is a common one too. I've injected sample after sample and I'm not getting any peaks. First off, if you're not getting a peak, stop injecting more stuff, because that might mean that the column is clogged. And then just take a moment and run it really hot and really high pressure for 30 minutes to an hour. Do that a couple of times. Inject some acetone in there, the same high temperature, high pressure for 20-30 minutes. See if you get anything. Zoom in on the baseline. There could be little bumps here and there that's just stuff coming out. That's kind of our purge bake cycle that we would have you do before we have you send it in. But if that doesn't work, then you need to contact us. So there's no user serviceable items other than the septum that I just showed. You can't change the column yourself. You can't replace the detector yourself. So you have to contact us, and then we issue you a return authorization. You ship it to us in that black foam lined carrying case. So make sure you keep that case as well. You ship it back to us. We take a look at it, make sure we can reproduce the issue. And then the manufacturer will take a look at it and recommend either like the column is clogged, so they can usually trim the column. Sometimes the detector needs to be replaced, things like that. Those do all have fees associated with them, but they are all less than replacing the Mini GC. So it is always worth at least sending it in to get looked at to see how much it would be to cost to fix your Mini GC. Because the Mini GC right now is, I think, $3,000. And we've never had a maintenance bill on a GC that was anywhere close to that. So definitely worth contacting us and having you send it in. All right, how we doing? Any burning questions I need to pause for?
Nothing I can't handle right now. Grazina just asked me about where can we get SEPTA, and I said, yeah, so I can handle that.
Okay.
Thanks for the easy question, Grazina.
Awesome. Okay, so that was kind of the general questions that I wanted to go over. And now we're going to get into kind of some more specific separation questions. First off, you don't need to be reinventing the wheel. That kind of goes for all Vernier products, by the way. Remember, we have lots of curriculum on our website. We have lots of free experiments. We have lots of books on our website to help you get your Vernier product up and running the same day. The Mini GC is no different from that. In fact, the Mini GC comes with free experiments when you purchase it. So they are on the website for you to preview in their PDF format. You can download each one of these right now and preview them, review the chemicals, review the temperature pressure profile. So even if it's a chemical that's like similar to something you want to inject, like if you know I want to do some xylenes, that's this chemical isomer one, or BTEX, with some environmental applications, download that lab and look at it and run those samples. And then if yours is just a little bit, different conjugation or something like that, start from there. It's a great place to start. So don't be reinventing the wheel. That's my first advice to you. And then I did say these are PDF, but if you purchase the Mini GC, you will get it in its Word format. If you log in to your Vernier account and see where your books are, and then you'll be able to see it in its Word format. We also have those free experiments for the Mini GC Plus. The GoDirect Mini GC can do everything in the Mini GC Plus free experiment book. The Mini GC Plus cannot do anything in the GoDirect Mini GC book, really. However, you will see a little bit of a difference in the temperature pressure profile. In addition to that, we have sample profiles for the GoDirect Mini GC on our website. If you click on there, and you'll see lots of compounds and lots of temperature pressure profiles to review. And that's kind of what I'm showing here. The second experiment I kind of glossed over is what we're going to be working on right now. This one about column temperature and loading, because that is really the one. Gas chromatography basics is teaching students when you change temperature, what happens? When you change pressure, what happens? And that experiment walks you through it. So that's the data we're going to take right now. Here we go. Okay, so this is instrumental analysis. This is a free piece of software you download from our website, the Chrome web store, the Apple store if you're on an iPad or an iPhone, and the Android store. Okay, so I have my Mini GC plugged in via USB, but again, I could have it plugged in via Bluetooth. And then I'm going to click on gas chromatography because that's what I want to do. So this is the default temperature pressure profile that comes up. This is by no means extensive. It does not work for every compound. This temperature pressure profile was selected because it is the most common experiments we hear educators doing with the Mini GC, like separation of toluene and cyclohexane, separation of ketones, things like this. It works well for that. That does not mean it is the only temperature pressure profile you can use. You can adjust all of these parameters. In fact, I want to start off with a very high temperature, high pressure run, because I want to show you guys how to separate stuff. So I need a chromatogram that's all smooshed together. And the best way to do that is to do high temperature and high pressure. I'm going to go ahead and get that equilibrating, but other circumstances where you'd want a high temperature, high pressure is when you have larger compounds, right? You have like our xylene lab where we look at ortho and para-xylene and separate those out. Just the fact that you can separate out those chemical isomers is pretty unique to this GoDirect Mini GC. It's very, very sensitive. And doing that at like a higher temperature pressure or a high temperature, low pressure, those different combinations really help you separate out, isomers and anything that's really closely chemically related. I am going to be injecting a mixture of ethyl acetate, butyl acetate, cyclohexane, and toluene. And I'm going to be injecting 0.4 microliters of it. I do want to demonstrate the cleaning of the syringe, because especially if you're used to the Mini GC Plus, that was not super sensitive. It really wasn't all that important to clean it out. But because the GoDirect version is so much more sensitive, it's very important that you take some of your sample and put at least 0.1 microliters more than you would be injecting to make sure you clean all the inside, and then push it out onto like a chem wipe. And then before you do before you switch samples, so if now I was gonna run, xylenes, I would make sure I cleaned it really well with some acetone or a separate xylene sample, that I didn't contaminate my samples. Because I know with the Mini GC Plus, I got very complacent and was not cleaning my syringe very much at all. And now I have to clean it all the time because it gets very, you get contamination peaks in there. All right, we're still waiting for this to get up to 95. Any other questions coming in that we want to discuss?
Melissa, is there a reason why we don't have a GC that can handle water?
The reason for that is because the manufacturer we work with to make the Mini GC, the Seco Science, they do polymer-based detectors, and that is kind of their specialty. And so to do one that can handle aqueous samples is a much more involved process and much more expensive.
So I just saw a question pop up. I'm trying to read. Is it just the detector in the GoDirect Mini GC that is responsible for enhanced sensitivity, or does the column contribute similar number of theoretical plates in each column, or are they interchangeable columns between the Mini GC Plus and the GoDirect? It's a lot of questions in there.
Yeah, that's good. Let me inject and we'll get into that. Okay, so I am gonna inject 0.4 microliters of this mixture. I am going to guide the syringe, and we talked about this earlier. Sometimes it does feel like there is resistance, especially early on. You just give it a little twist one way or the other to guide it in. I like to use 2 fingers, one right here on the fragile part and one up here. And then I'm going to push down on the plunger and press the white button at the same time.
Isn't that cool? That blew me away the first time I did that compared to the old Mini GC where you had to like bumble fingers around.
Yeah, if you have a Mini GC Plus, you have to, there's a button up here to start, and you have to push with your mouse and then do your syringe at the same time. So you're kind of further away. Now it's nicer, you're kind of closer together. Okay, so let's tackle some of this question. Is it just the detector that is responsible for the enhanced sensitivity? That's a good question. I would say it's the majority for sure. It does allow us to, the change in column allowed us to get better separation. We had too much overlap between the polar and non-polar compounds with that detector. So really the column was just for better separation. So I do think that it is the majority of the detector that allows for the sensitivity. And the other part is similar number of theoretical plates in each column, or are they interchangeable columns? So they're not interchangeable between the Mini GC Plus and the GoDirect. Well, that's not true. So they have the same number of theoretical plates. They are interchangeable, but the reason we picked this column was so that users would get the best experience from injecting both polars and non-polars. So technically they are interchangeable. You can't purchase one that has the old column with the new detector. So hopefully that answered that question. All right, cool. Okay, so I set this one up as this chromatogram. It looks like it's all 4. I know I injected 4 compounds, so all 4 peaks have come out. You can see they're all very much smooshed together. And I did that on purpose. I did a high pressure and a high temperature. But it's not uncommon that you would inject a sample and you're like, well, I want to get it through quickly, so I'm just going to turn all this up, and then it's all smooshed together, and you want to know how to separate these out, right? Or for example, with the xylenes and the BTEX case, if you just inject that at default parameters, they'll all be smooshed together just like this. In fact, it looks worse. It's kind of a big glob of stuff. So we're going to try and separate these out. And what the lab walks you through is adjusting the temperature and then adjusting the pressure. So let's see, we kept this one at 95 all. So I'm going to go ahead and stop data collection. And then it's like, are you sure? It is important that if you know you injected 4 compounds that you want to see 4 peaks, because if you leave stuff in there that just is asking for the column to get even more and more clogged. So make sure you've kind of let all your sample clear. Stop data collection. And now it's So by default, in between runs, it's going to equilibrate itself back to like 45. So that's important to know if you're doing a lot of high temperature runs. You kind of want to do them back to back. That's also why I start with high temperature runs, because I know it's going to go down over time. So it'll go a lot faster if you start with your high temperature runs. Let's see, let's do a couple of things here just so I can show you instrumental analysis a little bit. One, I can turn on a data table and I can turn, well, the meters aren't important for the GC, but I can turn on the data table if I wanted to see that. Typically, we're not seeing that kind of thing, so we just have it default to the graph. But I can rename this data set, and I can do that by clicking on the y-axis. It's defaulted to data set 1. I'm going to rename it, and this one I'm going to call high temperature. Because the sample I'm injecting is all the same 4 compounds, I'm actually just going to give the graph a title. And I do that by going into this little graph tools, edit graph options. And then I'm going to call it, this is ethyl acetate, cyclohexane, toluene, and butyl acetate. Okay, and then there's my title. And so now I'm ready to do my second run. I'm going to click on initiate data collection. Now I'm going to do an all low temperature run. So students can really see the difference between if I've started out with a high temperature, I'm going to switch it to a low temperature. And I'm going to keep it at 21 kPa at a high pressure, because you should only change one variable at a time if you want to actually figure out what's going on. And press apply. And then we're going to wait for that to get down to 45.
Hey, Melissa, I got a question I've never tried myself.
Yeah.
While you're waiting, can you change the time axis to different units, seconds, minutes?
No, not. Okay. No, it has to be in minutes. It's how all the firmware is set up. So it's not a user changeable thing. I don't know that you'd want to be taking, I don't know how many compounds would come out sub 1 minute for seconds to be worth it. If you were trying to compare it to something else in seconds, you could always make a calculated column of the x-axis and convert it to seconds. But you can't have it collect data in seconds.
Can you change the pressure units?
No, you cannot change the pressure units. It's kind of baked into.
Oh,
And pressure, yeah, and pressure is not really shown anywhere other than when you're setting up the profile, like right here in this screen. It's not really shown in like your table or anything like that. So
it's not a channel in there. I know temp is a channel, but
it is a channel. Oh, you're bringing up channels. Let me inject this real quick. So again, 0.4 microliters. The GC is ready, and I'm just going to inject the 0.4 microliters of the exact same sample, it's the exact same thing. We're just doing it at a low temperature. So yes, Nüs brought up channels. It is a go direct sensor. It has other channels. I can't show them to you during data collection, but something kind of nice about the go direct is that I can turn on a temperature channel and I can turn on a pressure channel. And it will actually, especially when you get into ramping and things like that, it will show you your temperature profile and you can overlay it with your chromatogram. The pressure doesn't change throughout the experiment, but you can see if you forgot, or if you're doing several runs with different pressures and you just don't want to write it down. That's a channel that you have on in the background that you can turn on. To show that to you, though, I have to connect via Bluetooth. I can't show it to you via USB. So if we have time at the end, I'll show that. But it's also described in the user manual and things like that.
I lost track. What did you change for this run?
This is temperature. So I went from 95 all So I'm just doing isothermic runs here. I'm not doing any ramping whatsoever. So 95 all. And this now I'm at 45 all. And I'm still at 21 kPa. So it automatically hides when I start a new run, it automatically stores and hides the previous data set. So it's not disappeared, it's not gone forever. I just have to show it if I want to compare, which I do since I changed the temperature and that's the only thing I changed. And I go to do that, I click on the y-axis and I click on my high temperature run. And you'll see already there's a huge difference. All 4 peaks had come out by this time, and the blue run is the low temperature. And now we have 2 distinct peaks for these first 2 compounds, and I'm hoping the last 2 compounds are still going to come out. And I'm going to go ahead and rename this low temperature. And I can turn on a graph legend in case we have forgotten which is which. And so next, so we're gonna probably get pretty nice 4 nice peaks here. What the lab walks students through, since we're not gonna have time to do the whole lab here, but the lab walks students through now ramping and how you can see like these 2 peaks are still kind of close together. So ideally you'd want to get those a little bit more separated. So ramping can help with that. It also walks them through lowering the pressure because that will make chemicals come through the column less quickly. So you can fiddle with all those combinations to make sure you get really good separation of all your peaks. I do want to say that we went ahead and injected a 4 compound sample. And we are just assuming the order of compounds based on boiling point, which is a decent assumption, particularly with the mini GCs. But if you want your students to do any kind of quantitative work with like identifying an unknown or doing concentrations, you definitely need to have them inject the singular compound as a known standard. So like I said, I have 4 in here, ethyl acetate, cyclohexane, toluene, and butyl acetate. I just want to have students run ethyl acetate through there and see where that retention time comes out. On that same temperature pressure profile, I want to have them run cyclohexane through and see where that retention time comes out. Again, with toluene, same temperature pressure profile, everything. And so they get 4 individual peaks for their 4 standards. And then you give them either an unknown or a mixture and say, okay, identify what's in this mixture, identify what's in this unknown. And that way you've set them up for success, that they've actually ran known standards and they know what those retention times are going to come out as. So that's obviously a different type of experiment. In fact, the next thing we wanted to discuss was applications. And that is a great application for high school chemistry, particularly for if you're doing like some forensics chemistry. I know Nüs just wrote an experiment that does exactly that with a really kind of forensics theme. I don't know, Nüs, if you want to give us a little sneak peek about that lab.
Yeah, as Melissa was describing a minute ago, it's exactly that. Students build their own little mini library of knowns. And then what they do is using that same profile, then they run samples that are supposedly, taken from suspects in an arson and compare their library to the samples from the suspects. And the retention times are the most important thing there for the students to identify what the components of the samples are. I made it very simple because I know the limitations on time in high school, but you could certainly extract it a lot more and do something like what Melissa's showing here. That's a phenomenal separation compared to the first one.
Yep, temperature does a lot, pressure does a lot. And yeah, like it's the exact same sample. So a lot of people think that when they inject this first one, that they're never going to get a good chromatogram on the Mini GC because I put it in at defaults and this one peak's huge. These 3 peaks are tiny. I can't see anything. You just got to play with that temperature pressure profile because I promise you, you can get all 4 peaks to look nice and separated and to have a good detection ratio. And that's why I highly encourage people to look at the labs and start with the labs, start with our sample profiles. It's really setting you up for success. You don't have to spend a whole day in the lab fiddling with temperature and pressure and all these things. I'm going to go ahead and stop. All 4 compounds have come out. Oh, I did look back at that comment. Yes. So the whole thing about the x-axis being in minutes, that is just for the go direct. The Mini GC Plus and the original Mini GC were in seconds. So yes, that is true. All right, so I'm going to stop data. And I could make this a little bit better. Like I said, I could probably lower the pressure or I could do some ramping to kind of separate this out. But I don't want to make you guys sit there and watch another 8 minutes of data collection. I can also get this baseline to be a little bit flatter with that. But for right now, I'm just going to show you some analysis. So if you used Logger Pro, which it sounds like a lot of you have, there's peak integration built into the software. So in order to do that, I select my first peak and hit peak and add peak integral. And now I get my retention time, my area, and my percent area.
Listen,
And
it's a mixture with equal volumes of the unknowns.
so yeah, this is an equal volume sample.
Okay.
So I did 1 milliliter each into my sample. Oh yes, so there's a question came in.
Question was about that, and also what's the detector?
No, so of course it's not going to respond identically for all the compounds. It can see certain compounds better than others, of course, because it is polymer based, and that's kind of a lot of the detection method. So, but I started with 1 milliliter of each. I hope that answers that question.
Yeah, there was a question about you had only changed temperature, and that's just because of time. You can certainly change the pressure, but there's the pressure change. The pressure setting is constant for the whole run, correct? You can't.
Right. Yeah, we don't have any plans to do a variable pressure setting. I'd be interested to hear how people would want to use that. If you would have variable temperature and pressure, that's kind of a lot for students to handle. But if you have an application, definitely send it to us. chemistry@vernier.com.
Sorry, I interrupted your peak integration.
Oh, no, you're fine. I was just showing peak integration. It's pretty simple. I'm assuming that ethyl acetate's my first compound because it's the smallest. And then I'm going to go in here, and again, these two should probably be separated a little bit more for me to do any analytical or quantitative work with this. My second one should be cyclohexane, and then toluene. And then butyl acetate. And right now, if I save this, or if I save this data, I can also do a, so from the kind of the file menu up here, I can save it, and that will save everything exactly as I see it. It will save my peak integrations, and it will save the names of the runs, but it will make it so I can only open it in Vernier land. So I can open it soon. We'll be able to open it in GA with our new version of GA that's coming out in a week or two. And then I can open it in instrumental analysis.
GA is graphical analysis. But
Graphical analysis, yes, thank you.
we get
Yes.
so used to seeing.
I know. And it will have this information. If I want to just take my runs as a CSV, as an XY pair data set, I can choose export. And this will export as either a CSV, so I can put it into Excel or some other type of graphing software, or I can just get a graph of the image, and that will it will preserve the peak integrals and all that kind of stuff. So that is the saving features, but other than that, it's a pretty simple interface. The reason we developed instrumental analysis, can you import CSV to GA? Yes, you can copy and paste. So you would open it in Excel and copy and paste it over into GA, but you can open the file directly in GA. So I would do that first.
You need to look at the bottom of GA when you're opening a file. There's an option there that's not immediately obvious that allows you to switch over and make GAC CSV files. So when you first go to open in GA, look at the bottom of the screen, and there you'll notice something you can click on that lets you change what GA can open.
So I was saying that the reason we developed instrumental analysis, since several of you are familiar with Logger Pro, we crammed everything into Logger Pro, and it really wasn't ideal. Like, you have, especially with spectrometers, you have to go through and fumble through some weird settings to get it set up correctly. The GC, it's time-based, so it was a little bit easier, but there's so much in that UI that is overwhelming to students, especially now, because it's an older looking piece of software. We decided to separate out spectrometers into spectral analysis, and then the instruments, the GC, the polarimeter, and the cyclic voltammetry system into instrumental analysis. So we could really make a good user experience right off of the bat, instead of you having to like figure out what settings and having to like go through the lab and figure all that out. It really is a lot more plug and play now with instrumental analysis. And I don't want to forget LabQuest, the GoDirect Mini GC. All of our Mini GCs work with our LabQuests, LabQuest 2 and LabQuest 3 via USB. And the setup for those is in all of the labs that we have written for you. We usually have a separate line item for showing you how to set it up in LabQuest, but it's pretty easy to figure out as well. All right, let's see. We got some more questions coming in. Okay, so the GoDirect Viz spectrometer works with spectral analysis. So all of our spectrometers, the GoDirect SpectraViz Plus, the GoDirect Visible Spectrometer, the UV-Viz, and the UV-Viz Fluorescent Spectrometer all work in spectral analysis. If you have not played with spectral analysis, if you are still using Logger Pro and spectrometers, stop it. Stop it right now. I'm here to tell you it is an infinitely better experience to plug your spectrometer into spectral analysis. If you have old SpectraViz Pluses, if you have original SpectraVizes, all of those you need to be using them with spectral analysis. If you have ocean optic spectrometers, you have to keep using those with Logger Pro, but all of the Vernier branded ones you should be using with spectral analysis. It's such a better experience. That's also a free piece of software you download from our website or the appropriate app store. Download it, try it out for 10 minutes. You'll definitely agree with me.
It's gorgeous.
Let's see. Once you know the area of a known concentration of a known substance, can it be used to determine relative concentrations? Yes, absolutely. As long as it is under the same temperature pressure profile, you can absolutely use a known sample to determine the concentration or volume percent in an unknown. I believe we have a lab that does that. We have a lab that does kind of a calibration curve. So that's what the recommended way to do it, right? You would do a series of known standards, different concentrations, and then you can do that, get your unknown and take that area and apply it to your unknown to make it quantitative. That's the best way to do it if you want to be really quantitative about it. But yeah.
That's also going to be device specific, right? If you try to compare that data on a different
Right.
device, it's not going to look the same.
Yes. Yeah, it all has to be on the same mini GC, all the same temperature pressure profile. You can't have each student in your classroom, for example, do one chemical and then use that information to determine an unknown. You won't get good results. You have to be within the same instrument, the same temperature pressure profile.
Right. Are there any options for subtracting a slope baseline and dealing with overlapping peaks within the Vernier software?
Oh, I just want to answer this one before. The Mini GC Plus works with instrumental analysis. All the Mini GCs work with instrumental analysis, even the original one.
Sorry, I missed that one.
That's all right. Are there any options for subtracting a slope baseline and dealing with overlapping peaks within the Vernier software? Unfortunately not. So a baseline subtraction is something I've been wanting them to add to instrumental analysis. But for right now, the best option you have is to do a manual baseline subtraction, which requires exporting out of IA, of instrumental analysis. And that's why I'm really excited that you're about to be able to open instrumental analysis files directly in graphical analysis, because graphical analysis will let you do some calculated columns and some baseline subtraction for that. But if you do a run in instrumental analysis of just background, so you don't inject anything, you use that temperature pressure profile and just do air, you might see a little bit of a shift here and there. And then you can use that as a baseline run, then run your sample, export those both over to it into Excel or another graphing piece of software, and then subtract off that baseline run. That's the best way to do that. Same thing with overlapping peaks. If you know you're doing one of the labs we keep acetone in there constantly to make sure that you're getting as quantitative of a result as possible. So instead of doing it from zero, so instead of using like the retention time that's relative to zero, you use the retention time that's relative to acetone to make it as quantitative as possible. If you want to subtract off that peak, or if you want to get rid of it in an overlapping peak, like in this case, you have to do that in another piece of software. But those are all great tools for doing these experiments with the Mini GC. Let's see, we're almost out of time. Is there any other questions? Anything else? Let's see. Oh, we were going to talk a little bit more about applications. Nüs, why don't you tell us about how you used it in the high school setting? I know there was definitely some people in here that wanted to hear about high school applications.
Well, I've been playing around with GCs since the early 90s, using Logger Pro originally because Vernier didn't sell one. The idea being that when you're teaching physical chemical properties, particularly the importance of separating mixtures in chemistry, chromatography is right there in the center of all the discussion. So I used to do paper chromatography, column chromatography, and with my own homemade GCs, I did some gas chromatography. But now, I mean, that was a pretty limited device that I built. And so now this is giving us a lot more options. And then, talking about intermolecular forces and trying to apply, those concepts to how these devices, all these different ways of doing chromatography, take advantage of that is really important, particularly in the AP Chem course, but even in the regular Chem course, if you're talking about intermolecular forces and polar and nonpolar compounds. And like I said, I'm writing a forensics book that we're all collaborating in here at the office in the Chem group. And one of the activities in there is that simple discussion that Melissa did earlier about building a very simple library of known compounds and then comparing it to a mixture that is unknown to the students. We're calling that a accelerant, that was supposedly used at an arson. But even in organic chemistry, depending on your school and whether that's part of your curriculum, there's an awful lot of applications and experiments, and we do give away on our website a number of experiments, some of which you can do even at a high school level. So I would encourage high school teachers that are interested in using this device to take a look at the website and see what's available there. And just remember that our lab manuals are quite a good deal because you only buy one, and then you can use it all you want with your classes and even modify them. So
Yeah. Oh,
talk
we got
fast there because we're running out of time.
yeah, we have. I'm going to answer this last question. Will you be having a session on the new spectrophotometer with fluorescence options, or maybe a video exists already? So we have several previous webinars that we've done that show the fluorescence capabilities. I would highly encourage you to look at those, but that's a great idea for a webinar. If any of you have ideas we're planning for next year, please send them to us. This is how you can contact us, chemistry@vernier.com. Maybe you have a very specific application for fluorescence or for Mini GC that you'd like to see, polarimeter, cyclic voltammetry system, pH. we have all kinds of stuff for chemistry. You're talking to two of the three chemists here. So shoot us an email, chemistry@vernier.com. We'd love to hear your suggestions for webinars. And also
I'll teach you. I'm writing an experiment called Secret Messages, and it's going to use fluorescence.
Yeah. But definitely also navigate on our website to the previous. So it's a little bit difficult to find. I'll go ahead and from Vernier.com, educator training, webinars, and this is where you sign up for like upcoming ones. But if you scroll all the way down to the very, very bottom, you can click on browse webinars. And we've done several, and I mean, I'm a spectroscopist by training, so I love the spectrometer webinars. I did a really fun one that was called Illuminate Spectroscopy right here, that went through all the methods that the spectrometers have. So it went through absorbance, percent transmittance, fluorescence, and emissions. So that's a really good one to kind of skim through. And we have several in here that use the spectrometer, selecting the right spectrometer for you. Shows off a lot of different qualities. So definitely look through those. And if not, shoot us an email. But I don't want to take up anyone's time. So thank you all for coming. And definitely come. Hopefully we'll see you in another webinar here soon.
Great to see everybody, sort of.
Yeah. Have a good one.